Okay, lesson 6. Sometimes you need to add or subtract algebraic expressions. When doing so, remember that you can only add and subtract the like terms. It's just what we did. You know that subtracting rational numbers is the same as adding its opposite. Likewise, subtracting an algebraic expression is the same as adding its opposite. Number properties such as commutative property and the associative property can help you add or subtract algebraic expression. The distributive property can help you expand an expression. So let's look. Subtract. Okay, this is key. 2x minus this whole part. Basically, this minus sign makes everybody behind it change. So I will have 2x plus 3, then minus an x, and then minus a 4. And when you look at it this way, you say, okay, my 2x and my minus x have to come together. 2x minus x, and this is 1x. There's 1x. You see 1x, there's 1x. So 2x minus 1x makes an x. Those two together. A positive 3 and a negative 4. A positive 3, so positive 3 and a negative 4. Put them together, and you're left with negative 1. So my final answer is x minus 1. Okay? Don't look at all this. Do it my way is easier. All right? X minus 1. All of this is really this. Okay? Remember, when you have a minus sign overpowers everybody behind it. It makes everybody change or do the opposite. So x was positive, it's now negative. 4 was positive, it's now negative. And then just do your same rules. All right? You will get this. It takes practice, but you will get this. Let's look at page 25. Okay. A quadrilateral triangle has 3 sides. Triangles have 3 sides. Quadrilateral means it's the same size. Oh, excuse me. An equilateral triangle. Equilateral triangle means equal sides. Okay, they each measure 2n plus 3. 2n plus 3. So if we think of a triangle, one side is 2n plus 3, the other side is 2n plus 3, and the third side is 2n plus 3. Find the perimeter. To find the perimeter means you always add them all the way up. It's the same thing as saying 3 times 2n plus 3. 3 times, what's the side? 2n plus 3. And how many are there? There are 3 of them. So I distribute the 3, I get 6n, right? Distribute the 3 to 3 times 2n and 3 times 3. 3 times 3 is positive 9. Okay? 6n plus 9. All right? This is a lot of working it out that I don't think you need to worry about if you can just understand the concept of 3 sides. They're all the same size. 3 times 2n plus 3 is 6n plus 9. So the perimeter of the triangle is 6n plus 9. We just don't know what n is, right? But that's how we represent it, 6n plus 9. Let's try this one. Find the sum of this plus this, then factor the sum. Okay, so let's do 3 times x plus 6. And then I want to add to that a whole 3 plus 9y. Okay, well this I have to multiply. 3 times this makes 3x plus 3 times 6 is 18 plus 3 plus 9y. Now I scan this whole row here and say, what like terms do I have here? The only like terms I have, really, I have 3x and I have a 9y. Can't combine them, but I have 18 and a 3. These are the only ones I can combine right here. So I'm going to write 3x plus 9y, plus 18 and 3 more, 21. Okay? So don't go through all this work. There's a lot of work over here for something that's not all that bad. All right? So we end up with 3x plus 9y plus 21. We'll just leave it at that. Don't even bother. All right. The greatest common factor of the 3 terms is 3. Okay, so this is interesting. I like this part. Watch here. 3x plus 9y plus 21. If I wanted to break that down to a multiplication problem that created that, the common number here in each one of these terms, I have three terms. I got one term, two terms, and three, right? 3 and 9 and 21. The common factor here is a 3. So I can take out a 3. And I'm doing distributive property backwards. So 3 times x made 3x, correct? Good. Plus, because 9 is positive, 3 times what makes that? 3 times 3y. 3 times 3y made that. Because I divided 3. How many 3s are 9? 3. So 3 times 3y makes that. And then what's 3 times what would make 21? 3 times a positive 7. So if I use my distributive property, kind of work it mental math backwards, I get that answer. So if I had to factor this out, this is my answer. Okay? So it would be plus 3y plus 7. 3 times x plus 3y plus 7. I did it right here. It's called factoring. Factoring undoes the distributive property. Does that make sense? Okay. So, where is page 26? I know, 26. Oh, sorry, 26 is on the back here. How can you rewrite a subtraction problem such as this? Okay, so this negative sign distributes to them. This negative, the negative sign distributes to all that follow. And make it and they do the opposite. Do the opposite. So if it's positive, it becomes negative. If it's negative, it becomes positive. How do you factor an algebraic expression? You do distributive property in reverse. Distributive property in reverse. Or backwards. However way you want to describe it. Okay? All right, so this plus doesn't change them. That plus has no power over this, so this still says is a plus x, and I'm going to put it right under it. And this negative 1 stays a negative 1. And now I'm going to add down. Combine like terms. X and x makes 2x. It does not make x squared. They're adding. X and x makes 2x. A 6 minus 1 makes a positive 5. So my answer here is 2x plus 5. Okay? Same with this. This plus does not change anybody. So I'm going to bring these guys all over to here underneath. 6n goes under 4n. And the 2 is a positive 2. Now, add up my like terms. 6n and 4n make 10n. A negative 3 and a positive 2 makes negative 1. So 10n minus 1. Final answer. Let's do this one. This plus doesn't change anybody. So again, bring them under. This x is going to join up with him, and this negative 8 is going to join up with him. 3x and x makes 4x. A negative 1 and a negative 8 makes negative 9. So 4x minus 9. Same with this one. This plus doesn't change anybody. So I'm going to do 4a. And this b is a positive b. How many a's now? 7a. Uh-oh. Negative b and a positive b makes 0. So you don't even write it. 7a. Okay? Find the difference. This minus changes everybody. Okay? So this d is now going to be a negative d, and this 2 is now going to be a negative 2. So it's 9d minus d. 9d minus d makes 8d minus 2. 2 doesn't have anybody, so 8d minus 2. Okay? This minus sign makes each one of those change. So it'll be a negative k and a negative 3. Put them underneath. Negative k and a negative 3. Uh-oh, what do you notice? They cancel out. They cancel out. Yeah, answer 0. Okay? This one. This negative sign changes him to negative 3p. And this negative sign changes that negative to plus 1. Put this over here. Negative 3p to negative 3p and a positive 1. Add them down. 7p and negative 3p makes 4p, right? 4p. 4 and 1 makes plus 5. Okay? All right, be careful here. This negative, I'm going to make this a positive. This negative is going to make this a positive. So I go plus m here and plus n. 6m and 1m makes 7m. These two make together 2n and another n makes plus 3n. 7m plus 3n. All right. Okay, let's solve this one. Your answer will include an algebraic expression. All right, Brad is this many inches tall. Oh, yeah, sure. If he grows this many more inches during the course of the next year, write an algebraic expression will represent this. So he starts out at 10x plus 11, parentheses, plus x plus 3. What's my answer gonna be? 10x and x, that makes 11x, and 11 plus 3 makes 14. There's your answer. Okay? Page 27. You are to try by yourself a little bit, and then I will do.